Let me introduce today's gurus. So first of all, we have Szilárd Barany taking the lead today. Szilárd is a senior solution architect with TigerGraph and one of the main contributors to the pyTigerGraph. And he's ably assisted by Richard Henderson, a lead solution architect with TigerGraph. So without any further ado, let me hand over to you, Szilárd, for the rest of the webinar.
Thank you very much, Deb. Hi, good morning, good afternoon. As Deborah said, I'm Szilárd Barany, I'm a solution architect. Before I do anything, I would like to apologize in advance if during the webinar I will say something that deeply offends the data scientists in the audience. I'm not one of them, and I admire their work. I'm not fully familiar with the subject area, so if I made some mistakes or something that is not data scientifically correct, please forgive me. But let's see what we are going to talk about today. After talking briefly about TigerGraph, I will introduce pyTigerGraph, recalling its origin, and then I will provide an overview of its functionality illustrated by examples. Then I will review the ways TigerGraph supports machine learning and artificial intelligence, followed by a very convincing demonstration of the same by Richard. The last section of the webinar will go through recent developments and future plans, then a quick poll to see what else might be interesting and beneficial to you, plus a glimpse at what community resources are at your service. And the webinar will close with the usual Q&A session. As Deborah said, if you have any questions during the presentation, please feel free to use the Q&A box. And if it's something that is absolutely relevant on the spot, I might answer that. The rest will be answered at the end of the presentation. So, we're TigerGraph. We are a company that aims to help our customers to improve the world with deeper insights. And when I say deeper, I mean it both figuratively and literally, both better understanding the data, and it's where you derive from analyzing the relationships, and on the other hand, the deeper links analytics, more hops between vertices that was possible before. And this is enabled by the only scalable native graph database for enterprises, which is foundational for AI and ML solutions. TigerGraph is a graph analytic platform that in addition to OLAP workloads can efficiently handle concurrent OLTP style of use as well. And its SQL-like language, GSQL, shortens the developer time to solution, although with the recently launched 3.0 version, you can get this to the solution in many cases even without writing a line of code. I will show you this soon and how it's linked to pyTigerGraph. TigerGraph was founded in 2012, and we released the first version of our products in, I think, around 2015. Despite being a relatively young company and product, we already have a good number of customers worldwide, with some big names amongst them. Our progress and solution are recognized by the market research companies and industry journalists. One of the recent recognition is being put on Gartner's Cool Vendor list for this year. So what is pyTigerGraph actually, and what services it provides? To understand its role, let's quickly review the means of interaction with the TigerGraph database. The most known and probably most frequently used way is Graph Studio, our graphical web application that allows us to design graph schemas populated with data, and export a graph, develop solutions based on the insight gained during this exploration. It's a very intuitive visual graphical application. And by now, with version 3.0, you can do almost everything literally just with clicking, no coding required. For example, starting with this version, you can migrate data from relational databases with a few clicks and typing some information in, or visually build the queries, as I mentioned, without writing a line of code. So Graph Studio is a very popular tool, but it's a tool for humans and not really for downstream consumer applications. Another tool for human interaction is the GSQL command line tool. While working with a graphical interface like Graph Studio is easy, sometimes working with a command line tool gives one more flexibility, more power, and I create my graphs from command line is definitely a good opening line at a blind date. It wins hearts. The GSQL command line, on the other hand, can also be used by other tools, for example, by scheduling and workflow management tools to initiate background tasks in the database or to extract results into downstream data pipeline. Finally, and this is the most relevant for this presentation, TigerGraph has an extensive REST API that provide a great variety of endpoints to work with the data and the queries in the database. This API delivers results in a JSON format, and this in fact is great for all kinds of consumption, especially in app-to-app communication. pyTigerGraph started as a Python wrapper for this REST API. Initially, it mainly allowed query executions. Then it covered some basic functions before we covered almost all of the REST API endpoints. Along the way, some convenience functions were introduced, so it's more than just REST API coverage by now. And some new features were added that use queries or GSQL statements that provide functions that is not available via the REST API. So what are these functions and how you can get started? So let's see, but I need to warn you in advance, the next few slides will carry all the charm of a technical documentation, so I will try to make them short and illustrate with examples. Installation of pyTigerGraph is nothing special. It's the usual tip way. At this stage, installation via Conda is not yet supported, but it's in the plans. Once you have it, you just import it and then you create a connection. Since we are working with the REST API in the background, there is no real connection. It's not something that needs to be kept open or closed at the end. The Python function calls will be converted into individual HTTP requests. The information that you need to provide to set up a connection is very few pieces of information. The base URL, including the protocol of the host that runs TigerGraph, the graph name, the database username and password, and if REST API authorization is enabled, you will also need to provide a authorization ticket that I will talk about later. Additionally, you can specify the port of the REST API and the GSQL server. If these are not the default ones, if they are mapped, if these are not the default ones, for example, if they are mapped in the virtualized environment. Actually, we have default values for all of the parameters, and as you will see soon in the demo, so basic development in the basic development environments, you can establish the connections without specifying any values. I just realized that I might have skipped one slide. Yes. Actually, I don't know how did I did. Let me talk about a little bit of origins. Sorry for missing this slide. So as I mentioned, TigerGraph is a relatively new product from a relatively new company. And to help it grow, it is important to ensure that it fits into an existing analytical ecosystem and has integration points that allow data analysts and data science practitioners to work with it. After all, as John Donne, English poet, scholar, and soldier wrote in 1623, no database is an island entire of itself. So one of our goals is to provide these integration points to allow TigerGraph seamlessly fit into the technology and analytical stack of our customers and other users and researchers. At the same time, as more and more customers and researchers started using TigerGraph, a community formed to discuss, share, and very importantly, to create and contribute. The need to connect TigerGraph into the Python ecosystem was one of the first manifestations of this willingness, reflecting the relevance of Python in data engineering and data science. pyTigerGraph was initiated by a university student, Parker Erickson, based in the US. His projects coincided with the same initiative inside TigerGraph that we started as a response to customer and prospect needs. Since we found having an active community and encouraging creativity important, was in there, for example, the Graphathon we recently announced, we decided that tapping into the creative flow of the community is the best course of action, and we joined the initiative. TigerGraph is a community project, influenced and directed by the community, although obviously we contributed as much as we can, both in code development and guidance. The project is community supported, meaning that it is not covered by TigerGraph's license and support agreement, but through the community forum and chat, we provide as much help as we can. TigerGraph has recently been moved into full community ownership, and the governance in open source community terms is being formed around this. I will talk more about various community resources, sites, and links, and our community evangelist at the end of the presentation. At this stage, I just would like to show you that we do actually have the GitHub repository for pyTigerGraph, and we have a fairly good, up-to-date, and detailed documentation for this. And coming back to the slides where I was. So, as I said, all you have to do really is to import pyTigerGraph and establish the connection by specifying the few parameters. Let me show you how it happens in real time. I'm using a AWS instance that I connect to from my local Jupyter notebook. And I've created the notebook here for demonstration purposes. So I just imported pyTigerGraph, and because I'm using standard port, standard information, standard connection details, I don't need to provide all of this information, but obviously it's very flexible. You can provide whatever you need. So let's execute this one. To be able to present the results nicely, I will use pandas, data frames, and JSON as well. So coming back to the slides. Let's see what are the actual functions. First, let's see how you work with vertices or nodes. You can first get a list of vertex types defined in the graph. And by the way, let me show you what I'm talking about. As I mentioned, I'm using a graph, obviously, in AWS. This is actually a COVID-19 data model and data set that we have developed. This is available through our starter kit. I will refer to this later, so you can play with the data set. The most important vertices in this data set is the patient with the details of the infection, the travel event, where what travel event the patient participated in, effectively where he or she traveled to. There is a self-referencing link here to showing who infected whom. The infection cases show locations or outbreaks where a group of people were infected. We have a geographical hierarchy, country, province, and city here to record the infection locations, and we have some search information on weather and web searches regarding COVID-19. So I'm going to use this data set as an example. So as I said, you can get a list of these vertices defined in the graph, and in addition to that, you can get metadata description of each of the vertex types. You can also get vertices, vertex instances, vertex data by primary IDs. This is the fastest way to retrieve a vertex or direct access to the data set. Or you can retrieve vertices by applying a filter and optionally returning a selection of attributes, sorting and limiting the result sets. This is somewhat slower way to retrieve data because the entire data set has to be scanned, but it's more flexible, and starting with version 3.0, now you can create indexes on the attributes, so it accelerates data retrieval a great deal. You can also get vertex count, statistics, which includes minimum, maximum values, cardinality, things like that. And obviously, you can observe one or more vertices to create new entries in the database. One important thing here is that this is an observed, meaning that if a vertex with a given ID already exists in the database, there will be no complaints or warnings. The existing vertex attributes will be simply overwritten with the new values. While if you are inserting a new vertex, it will be simply inserted. And of course, you can delete vertices either by individually by ID or by specifying some condition. Let me quickly demonstrate this. So I'm first getting the list of vertex types converted into a data frame. So these are the vertices that we have seen here. I can get the details of one vertex, for example, the patient one, and it shows all of the attributes, statistics generated on this, the primary ID, and so on. As I said, the data is returned in a JSON format. This is what is shown here. Retrieving a vertex bar ID, for example, this patient is very quick, although this data set is not big enough to cause any headache for TigerGraph. Retrieving vertices using a filter is a more flexible way. For example, I'm looking for provinces where the area is bigger than 100 square kilometers. I want the list sorted by population decreasing, and I would like to see the top 5 provinces with cases. And there you go. You can get vertex counts, vertex statistics. Here you can see minimum, maximum, average values for numerical attributes. And here is an example how to insert and delete or upsert and delete vertex. The fiction province is not in the database, so I'm going to insert it. It's there, so I delete it, and it's no longer there. Very easy to use. We try to make all of this functionality simple, as simple as possible, so that data scientists can focus on actually working with the data rather than the technicalities of accessing it. Very similarly to the vertices, you can work with edges, getting the types, the list of types, the individual type details, whether getting the information about the source and target vertex types, whether it's directed, and if there is a reverse edge associated with that. You can get the edge data individually or by type. You can get counts, statistics, observe and delete edges. Very briefly, without too much explanation, I just go through these. So I'm getting the list. These are the edges, getting some information. This is all the information. This is broken down to source vertex types, target vertex type, directional information, and reverse edge. Retrieving an edge is very easy. I would like to start with a province called Gyeonggi-do and follow the city in province edge. There could be multiple edges coming from a vertex, so I have to specify that one. I only want 5 of those. And there you go. Getting a count, getting statistics on the attributes, and then observing an age which is not there yet, but it is now, as you can see. So let's drop it. That's it. Very easy to use, or at least this is the intention, to keep it as simple as possible. A little bit more interesting thing is to work with queries. A query in TigerGraph is similar to a stored procedure or function in a relational database. It's a named piece of code stored and executed within the database. This is the most efficient way of working with the data. You don't have to move the data to the code. You don't have to extract it from the database. Instead, you move the code to the data, and the code is almost always smaller than the data. If your data is smaller than your code, then you should probably use Excel, a legitimate analytic tool, no offense intended. Furthermore, TigerGraph is an MPP, a massively parallel processing system that fully utilizes the capacities of multi-core CPUs and the total memory of a multi-node cluster. So use all of this power at hand, and do not use TigerGraph just as a bit bucket pulling the data out from it into a laptop with limited CPU memory resources and too often running analytics in a single-threaded mode. You have a very powerful tool at your hand. Use it. The queries are written in GSQL, a fully featured query language that has procedural capabilities, so you can develop complex programs in it. In fact, we have a number of graph algorithms implemented in GSQL, so we didn't have to code them in C++ or machine code. our query language is very flexible and very capable to handle even the most complex graph algorithms. GSQL is similar, very similar to SQL, and it's very easy to learn, yet it's very powerful, especially if you master the use of accumulators. I'm not going to talk more about GSQL, the language. That would take too much time, and we have plenty of really good resources and materials to learn into this. But obviously, I would be happy after this presentation to answer questions either as part of the Q&A or later in email or through Discord. You can write queries by hand or build them visually. I mentioned that already. I will show you that a bit later. A query can be executed in two ways, in installed or in interpreted mode. An installed query is converted from GSQL into C++ and then compiled to machine code and linked to the database kernel. This approach allows the fastest possible execution of graph analytics. The query needs to be compiled only once, which might take sometimes, I mean, a few seconds, a dozen seconds or so, but then there is no other work to be done when you want to execute them. Compile once, execute many times. Installed queries also come with a REST API endpoint, so they are immediately operationalizable. On the other hand, interpreted queries, well, they are interpreted every time you execute them, so they are somewhat slower to execute because there is this little interpretation overhead every time. But there is this somewhat longish one-time compilation is not required. So if you are using Graph Studio or the GSQL command line, interpreted queries are the ideal way to quickly develop, test, and refine code. You just make a change, try it, refine it, delete it, or try it. There is no time. There is no need to wait for them to be compiled. Furthermore, in a programmatic environment, for example, when you are using pyTigerGraph, interpreted mode gives you the opportunity to build the query on the fly, so you can make your application a code generator, and then you can run it. So it's very easy to build queries and execute them from your code. So you have these two options, and you can decide whether your focus is on execution speed or on flexibility. In pyTigerGraph, in case of installed queries, you need to specify the query name and its parameters, while in case of interpreted queries, you provide the query code and the parameters. Let me show you this quickly. So in the database, I have this very simple query, which lists me the top 5 most affected cities within the province. I start with the province ID here. And I have an accumulator, a sum accumulator, which collects numerical values into the total cases. So as I said, this is very similar to SQL. We have a select statement here. We select from a relation starting with the provinces. Following the city and province edge, I would like to find cities. This is what I will select, using the target alias for the city. I'm looking for cities which are not the capital of the province. In South Korea, they have the same name. I would like to calculate the total cases by summarizing the elementary school, kindergarten, university, and nursing home counts of cases. I would like to order the results set by this total value, descending, and get the top 5 cities or edges. This will provide me with a edge set, and actually I can run it for you. So I'm looking for the top 5 cities in Seoul province. And here they are. And this is the visual representation of the result, but you can have a look at the original JSON output. But coming back to my presentation, so I have this query here to be executed, and I provide the parameter here. Actually, let's change it to Busan. Let's run. And here there are the top 5 cities in Busan province with the counts, with the case counts listed here. Interpreted queries, as I mentioned, you have to provide the code, and I'm actually just copy-pasted the same code here to show that there is no actual difference. The only difference is really in the execution when I execute this, the database has to go through this line by line, understand what it needs to be done and execute it. And it needs to be done every time, unlike in case of install queries, which is only done once. Let's run it. I'm looking for the top 2 sales cities. And here they go. Here they are. Now, I would like to take a little detour and show you something that I promised a number of the times, how to build queries visually, how to create queries that doesn't require writing a line of code. This visual query builder feature is new in TigerGraph 3.0, and it's very easy to use. So I would like to recreate the query that I was just showing to you. Here's an example, but let's start from scratch. So most affected city visual query builder number 2, yes. Okay, so I start by adding a vertex. I would like to start with the province, and I will provide the province ID as a parameter, which I called very creatively pro. The next element in my visual query will be the city. And I would like to put the city into the results set. And a slight orange glow and the orange background within the name shows that this will actually be shown in the result. And obviously, I would like to join these two, starting with the province to the city, using this city and province edge. But I would like to order the output by the number of cases. So I'm adding an ordering clause here. Let's make it a bit wider. So I would like to add together those 4 values, the counts. So I'm picking an expression here, sum. Because I'm going to add 4 numbers together, I have to make it 2-level addition. First, I'm picking a attribute which is the elementary school count. I add it to the other attribute called kindergarten count, plus the second step, I'm adding an attribute called university count, and the 4th one, which is the nursing home count. And I would like to see this order descending. Okay, so I now have a indicator that there will be some ordering, and I would like to limit this to the top 5 entries. Okay. So it's very simple. I really hope that I didn't miss anything. So let's save it. And I can immediately execute this for provinces of Busan. Run. And here are the 5 most affected cities in Busan. I forgot to filter out the Busan, but you can do that later. So this is great. You can create queries, fairly complex queries, especially if you use something like this widget, which allows you to create intersect, union, subtract of the subset of the result sets, and applying the filtering, aggregation, order by, and limit clauses. But you can also convert this into a GSQL query, the query that you don't have to write manually because the database will generate the code for you. If I save this, it will appear as a new query. And if I install it, I will be able to execute it. As I mentioned, the installation might take a few seconds. So while it's completing the installation, I'm going back to my slides, and I will come back to this a little bit later. Okay, what else is left? I mentioned that if your REST API is protected and authentication is turned on, you will need to get a token. A token is a temporary security ticket that you can use in your communication. For this, you need a secret. The secret can be generated within the database, typically by the admin who gives it to you. And then you can use this secret to request a token that you will use during the communication. You can ask for a refreshment of this token, although the original expiration time is, I think, some 30 days or so. And if you no longer need, you can delete the token. Authentication, authorization is actually fairly simple. Okay. What else you can do with pyTigerGraph? You can get the schema information, which lists vertices and edges, and you can get information about the user-defined types. One recent development is trying to expand this to cover all of the database objects, including loading jobs, schema change jobs, queries, and so on. It will be soon in the code base. You can observe data. I talked about observing edges and vertices, but if you want to do some bulk upload, edges and vertices mixed, you can use an additional approach for this. You can ping the database to see if it's alive. You can get the endpoints, both the predefined endpoints and your queries, which were converted, which are presented as an endpoint, so you can see what function is available in that version of the database. You can get system level statistics, version, and license information. Let's see if the installation has completed here. Yes. So now I have these 3 queries, and I can immediately run this VB2. And here are the top 5 cities or so. There is one more thing that I would like to show you, just to highlight what can be done, and one of the future things that we will provide in pyTigerGraph is visualization. I'm using the Cytoscape framework here, more precisely the Python version of this, which is called IPyCytoscape. It's a very easy to use framework, but we try to make it even easier by providing some functions for this. So I'm just importing and initializing this framework. Using this connector, pyTigerGraph connector Cytoscape, you can simply get vertices, you can specify conditions, you can get the edges belonging to those countries, and then you can get the vertices belonging to those edges. So it's very easy to get the data out from the database into visualization. I just fire up the framework. I provide some styling, colors, and things like that. And there you go. Here is your graph to demonstrate the results, to demonstrate your findings at the end of the your presentation. So next, we are getting there when we can actually talk about how TigerGraph supports machine learning, deep learning, and AI, and it supports it in 3 ways. First of all, through in-graph machine learning, then by providing tools for feature engineering with real-time deep link analytics, and then providing a platform for explainable AI. The graph database is an appropriate or even ideal platform for a number of machine learning and deep learning algorithms, in addition to a wide variety of statistical analytical methods. For example, we can build a recommendation solution using the time frequency, inverse document frequency method, and relation factor model, as it was demonstrated during the 20th Graph Gurus webinar. I recommend you to watch that. It was very interesting, a very useful presentation. And similarly, you can even use neural networks. You can implement neural networks in the database, for example, to recognize handwritten digits. Neural networks are effectively graphs, with the nodes in the various layers being the vertices in the graph, and the connection between these nodes are the edges in the graph. Graph Gurus 19 provides a demonstration of the aforementioned handwriting recognition using neural networks. The distributed and natively parallel nature of TigerGraph allows creating larger neural networks in multiple hidden layers to implement even deep learning solution. The next way is feature engineering. While, so a number of machine learning and deep learning methods can be created using the graph database. Some other approaches are better implemented in different environments, for example, in Python or R. But TigerGraph can help here too, and as you will see soon with very convincing results, through feature engineering by extracting features from graphs, features that would not be easy to produce or that would be simply unavailable in other ways. Here is an example of how well feature extraction using graph contributes to fraud detection. You can see the illustration here. One of the largest mobile telephone companies gathers 118 graph features for each of its hundreds of millions of subscriber phones to feed its machine learning detection engine. They build and update a detection model and then again extract the 118 features for each phone with every call in real time. And these features include information about the nature of the calls made, for example, number and duration of calls, the existence of three-hop friend relationships, and stable groups and number of calls within these groups and so on. A lot of things that can be only detected or that's only available in a graph. This generates a training data set with billions of new features, resulting in improved accuracy of the fraud detection. Where a graph database especially shines is real-time deep link analysis, detecting relationships and correlations between entities far away, I mean, within many, many hops from each other. Richard's demo later today will show how specific features can be extracted from the graph and how they can be fed into the machine learning model to improve its efficiency. The third approach where graphs can be used in data science is explainable AI. One of the biggest obstacles to widespread AI adoption in the government as well as in enterprises such as banks, insurance, and telecom companies is a lack of transparency in how the AI system arrived at a particular decision. Their clients would like to and deserve to know why a mortgage request or a welfare claim was rejected, but we have heard many stories that sometimes even the developers of an AI solution can't explain how their creation is thinking. News about racial and cultural bias of expert systems are frequent enough to question the usability and reliability of the systems and justify the demand to understand why these decisions were made. A graph data model is self-explanatory. It's visual, as graph analytics is effectively connecting dots. So explaining the results by following the hops between decision points in a graph is very simple and intuitive. So these are the three approaches. And now I would like to ask Richard to show his magic. I'm turning off screen sharing. Richard, your turn.
Thank you, Zilad. Right, I'll just see if I can get my screen sharing to work properly. Okay, I think that's the correct one. Okay. Hopefully, you should be able to see. Let me see, am I showing the right thing? So on the desktop, I want that one. There we go. So, can you see my? Yes, that should be working.
Yes.
Excellent. Okay, so what about what's on the screen here? So I'll tell us a little story. The story is that we have a lot of material that makes some very strong claims for how graph improves the situation when you're doing machine learning or anything like that, with graph features, or indeed just using the power of the graph to do very fast real-time aggregation and feature engineering, as we should call it. I felt that we didn't have a we needed to demonstrate this. We needed to make it very, very concrete. So what I did was I thought, well, why don't we try running it on something from Kaggle? So what I did was I picked payments data because that's something that I happen to have some experience of. And I knew how to build a payment system. I knew how they worked. And the basic problem with payment systems is that the amount of information you have when you run a transaction is quite small. It's just really, it's very, very limited indeed. And this particular data set, as much as it's synthetic, was pretty good data set. People generally like it. It has synthetic data. The data is quite clear. It's not obscured, and it looks like credit card data. So what you can see is you get the customer who's performing the transaction, some information, some demographic information about their age, gender, and stuff like that, which actually I ignore because it's not relevant, but nevertheless, it's in there. And also the merchant. So who are you buying something from? What category is the merchant? This is called the merchant category code, MCC, in credit card companies. And that's pretty much, and the amount. And then finally, this is a labeled data set. So it's for supervised learning. So ultimately, whether this was a fraud or not is given. And one of the things to note is just how unbalanced this data set is. It's the vast majority of things are not fraud. And if we look at, there's a few people who have run against this data set because it wasn't offering thousands of dollars in a competition. Generally, people, it hasn't got the hundreds of kernels that you get in those, like the Titanic data set. But nevertheless, there's a few people who had a go. And there's this guy down the bottom. He's a grandmaster of Kaggle. So I thought, okay, if I can beat this guy, then we're probably doing okay. And not only that, I can steal his work, as it were, and see if I can improve upon it. So he did the work. He's done this amazing analysis of all the data, lots of work, feature engineering, deciding what he needed to do. And one of the things that I used, which he did, he uses a thing called the cat boost classifier, which is a fantastically powerful classifier. But the reason I like it is because you don't actually need to be an expert in order to use it. Anyway, after all this work, looking at what was important and what was not, he ran his, and here are his results. And these are the results that I think are worth seeing here, which is that he detects a lot of the frauds, 1,800, but he's got a false positive rate of 150 and a missed fraud rate of 320. So that's what I've got to beat. If I could beat that, then I felt I'm actually showing something concrete. So what we did first, and I will get to the Python bit in a second, was design a schema. The schema is very simple. This is one of the beauties of graph databases, is that your schema very closely reflect what you'd expect it to look like. You have transactions in the middle with a bunch of information against it. You have the customer who's performing the transaction. You have the merchant who is you're buying from, and you've got the category of the particular category of what's being bought. So for example, if you're getting in a taxi, it would say ES transportation and so forth. This data was loaded in the usual way, straight from this data set. You'll notice this data here. This data is basically the data you download. I haven't touched it in any way at all. It's very easily loaded using the standard mapping tools, and it loads into all the edges and the nodes. And you load it, it takes, I can't remember how long it took. How long did it take? It probably says down here somewhere. Yeah, finished. 186,000 lines per second. So therefore it took 3 seconds to load that data. And that's actually probably spent 2 seconds starting the loading job. So it actually loaded it a lot faster than that. We can often get up to 400,000 or 500,000 lines per second. This is running on a small machine. Anyway, then I wrote queries. The queries effectively set up the aggregation, so the extra features that we want out of this. And ultimately, we end up with what looks like a fairly complex, although an awful lot of this is me commenting. This is what actually outputs the information. And I think the thing to note here is that when we start, where we started off with just 1, 2, 3, 4, 5, 6 pieces of information, which we're actually extracting, we're adding another 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 complex aggregates that we're adding on the end. And these aggregates are, some of them are pre-processed, but the vast majority of these are being pulled in real time. And I'd point out that the actual history of transactions which you can apply is a parameter here. So if you were generating these aggregates using a standard database, it would generally, it'd be very unusual to be able to specify how much history, because the aggregates would be completely aggregated. For us, I am not doing that. What we're actually doing is generating the aggregates on the fly. So as a result, it means that we can effectively do things like set the number of days history applied to a transaction. Okay, so it's just a Jupyter notebook, just as you'd expect. And this is what it looks like. So generally, it's just what you'd expect. You have a bunch of imports at the top. And here is the connection string exactly as Szilard described. Very simple. This one I happen to be tunneling through my local machine, and that's for security reasons. So I've actually got an SSH tunnel on my local machine, which is attaching to my database directly, or to the database machine directly on AWS, because it's on public cloud. Obviously, I want to maintain security. So that tunnels through localhost onto those ports, just exactly as he showed you. And the first thing it's doing is basically running that installed query. And there it is. That's the query that we saw. I already ran this. I'm not going to run it again and burn minutes. You know, our time is valuable, but you'll have to believe me. This is the output that we get out of it. And what you can see here is you've got the first few columns, which are the columns that you would expect as part of the transactional information, what I've called relational here. And then you've got these engineered features, which are the directly aggregated features. In this particular case, I'm using 5 days of history. We've run this with up to 30 days of history, but we find actually that when we change the day's history, we found that 5 days of history is about the right number to get the best results. So you've effectively generated a hyperparameter there, which is quite handy. First thing, the data, how unbalanced is it? We've got about 600,000 not frauds, and within that, about 7,200 frauds. So it's highly unbalanced. Normally, you'd have to do an awful lot of work to rebalance the data. But because we're using CatBoost, we don't have to. It's fantastic. So I tell you, if you're into classification, then check out CatBoost. It's well worth it. The columns here we define are the relational database columns versus the graph columns. We do the usual thing of splitting it. And the first thing we do is try it with what's called a dumb predictor. What this does is says that everything's not a fraud. And we can see on the top left that that's great. It's absolutely found all the not frauds because it says everything's not fraud, but 1,320 were where it said it was not a fraud when they are a fraud. So it's missed 1,320 frauds. So the idea is we can do better than that. So the first thing we do is we run the classifier, and this is just running on the 4 or 5 variables that we had, which we've pulled in. And the results here actually are pretty much state of the art. The guy who is the best at this, this is the results he got, 326. So they detected 994 frauds, 326 were missed. So these are the frauds that were missed. And he's got about 70 false positives. This is really good considering the minimal amount of information available, but there's 70, these are 70 annoyed customers where they tried to do something like buy something on holiday and they weren't allowed to because it came up as false positive, as it came up as a fraud when they ran the system. If we look at the features on the model, we can see these are the 4 features that they had available, and which merchant it was is the most important feature. So this is the explainability. CatBoost gives us a lot of features this way. If I run exactly the same, and when I say exactly the same, I mean that the features here, all of these parameters are precisely the same. I haven't changed anything. All I've done is change which columns it's allowed to see. And we run it again, and this is the result we get here. And what we're showing is, and I've put the previous results above it, is that with the graph features, we've almost halved the number of false positives from 70 to 45, well, very approximately halved. But we have definitely halved the number of frauds missed. So what we've done is effectively, by adding the graph features, we've doubled the performance of the fraud system. And that's simply by adding these graph features into it. And the beauty of pyTigerGraph is that now we can actually demonstrate this with all of this machine learning in place. We can do this in batch, and we can ultimately load this model into the database and run it in real time. And now we can see that the extra features which you've added, these are the ones that are actually turning out to be most important in determining the fraud. And there you go. That is the side-by-side fraud demo, or why graph features are good. Okay, back to you, Szilard.
Thank you very much, Richard. So let me quickly continue with the presentation. I share screen. Yes. Okay, so let me quickly talk about recent additions and future plans. The community around TigerGraph and specifically around pyTigerGraph is very active, and we have plenty of new ideas. The two recent significant functional improvements for pyTigerGraph are: one, enabling the execution of arbitrary GSQL code including data definition statements. This is currently done using the GSQL command line client, but we intend to bring the functionality to fully into pyTigerGraph. While Richard was talking, I had a look at the Q&A questions, and there is a question saying that, are we only able to interact with existing graphs, and is it possible to create new graphs via pyTigerGraph? With this new functionality, with this new GSQL code, you can do anything, including creating vertices, creating edges, and creating a graph from that. I'm not sure if this is the right thing to do. I would say that designing graph is the data model is a little bit more involved stuff than generating something on the fly. But who knows? But technically, you can do that. And the other new improvement is supporting Panda data frames, as you saw in both mine and Richard's notebook. You can now display, you can pull data into Jupyter notebooks, and you can observe the data of a data frame into back to the database. This can be done now with vertices and edges, and there is already a prototype to do the same thing with data return by queries. As you saw, we already have some experimental support for the Cytoscape graph visualization framework in Jupyter notebooks. We would like to extend this to Jupyter Lab and other platforms like Google Collaboratory, plus support other commercial and open source frameworks like Wi-Fi, Zoom charts, DC.js, Sigma.js, and others. We also want to cover the pathfinding algorithms provided by the REST API, the shortest path and the old path. We plan to support starting and managing loading jobs from pyTigerGraph so that it can be used more in data engineering tasks, not just in data science. And for the same reasons, we are looking at how workflow management tools like Luigi could be or needs to be supported. We already have a few examples demonstrating the use of pyTigerGraph in our GitHub repository, and more will be added, examples that are actually useful tools. For example, a DDL generator that covers all object types within the database. This would open up a lot of possibilities, for example, to support for code versioning, code repositories, for CDCI, schema and code comparison, and automated generation of schema chain jobs, and so on. Also, it could allow us to create tools for data export and loading job generation. And we are also looking at tools to convert from so-called standard graph serialization formats. There is no real true standard, but there are a number of candidates. So we would like to provide tools that convert from this format or allows them directly to import these into TigerGraph. Although this webinar is about Python support for TigerGraph, I would like to mention that there are already connectors being developed for the languages. There is one for C#, which has fairly good coverage comparable to pyTigerGraph. And there is one for JavaScript that I'm currently working on. This latter one is massively work in progress. The first iteration intend to work on client-side only and target data retrieval for graph visualization, similarly to what you have seen in the notebook. But I intend to expand this functionality to similar level as pyTigerGraph and support server-side Node.js development too. This is in early stage of development, but I intend to, it's already shared with the community, and intend to build up a community and then get help to develop this further. I would like to grab the opportunity to run a quick poll to find out what other language environments should we look at next for TigerGraph connector development. What would be the most useful for you? Please take a minute to vote in the poll. The URL is at the bottom of the slide. And I will check the results at the end of the seminar. So this is what you will see, a quick list. Feel free to add anything here. We will consider all of the possibilities. So it's tinyurl.com/TigerGraphGurus42, TGG42. I promised at the very beginning that I will talk more about the various community resources, sites, and links, and our community evangelist. So first, here he is, John Herkey, who put enormous efforts into building the infrastructure and the resources for the community. And thanks to these efforts, now we have a live and growing community. And what are these resources? We have a community forum. We have community chat using Discord. I'm almost always on Discord. You can access me. My details will be on the plus side. We are on all of the relevant social media channels. And we have obviously the documentation for pyTigerGraph and the GitHub repository as well. If you liked all of these, any of these, or what you have seen previously, you can get easily started for free. We have TigerGraph Cloud, which provides free instances for your use to learn and experiment with, or you can download the TigerGraph Developer Edition and run it locally in virtual machine or a container, or you can even use our test drive, the online demos where you don't need to do anything, just use the data and let's see what's happening. You can get certified, and as I mentioned, we have all kinds of community resources. I would like to draw your attention to the upcoming next webinar on Tuesday, 11th of August on next generation machine learning solution with graph analytics on connected data, which will be co-presented by with Xilinx. And with that, let's go into Q&A. Deborah?
Thank you, Zilad, and thank you, Richard. So we do have a couple of questions we can go to quickly as we're heading up to the top of the hour. So one question, what are the different sources you can connect to?
Well, generally speaking, TigerGraph can pull data from a number of sources. Obviously, you can upload files. You can upload files, both CSV and JSON files from local sources or from S3 buckets. We intend to cover more cloud box storage in the near future. We have a Kafka interface, which allows you to ingest data in a streaming fashion. You can upload data through the REST API, as we showed. And the new feature is, one of the new features of 3.0 is this database migration, code-free database migration from relational databases.
Okay, and one last question, actually, sorry, a couple of questions. Given that these are traversals, do the functions get vertices and get edges take longer to run if you have a larger data set?
Well, yes and no. Obviously, the more data you have, the more work you need to do. But as I said, with the introduction of indexes on attributes, this extra time is actually not that huge. It's fairly fast. In fact, with indices, you will not really feel the growth in the time as your data set grows.
Okay, thank you. And finally, where can I get pyTigerGraph?
Okay, so we just, if you have Python, it's very easy. You just say pip install pyTigerGraph, and it's already fully with all the dependencies configured. You can easily download it, or you can visit the pyTigerGraph repo on GitHub and clone it yourself. And I encourage everyone to clone it, participate in it, criticize it, give us recommendations. We would be happy to take into consideration real life demands.
Actually, we're just getting a few more questions. If people have time to stay on, we can cover them. Will the slides be shared? Yes, they will. And the Jupyter notebooks, will they be shared? Ah, yes, Richard, you're answering that, I can see.
Okay.
The answer is yes.
I can see, but one of the questions regarding the surveys others in the chat. I go back to this survey. Here you are. https://tinyurl.com/tigergraphgurus42.
Okay, and I think we'll just have one final question. Somebody who's new to data science and still in early learning phase, what resources would you suggest to learn graph database and theory?
We have a lot of resources on YouTube. We have I think by now 42 Graph Gurus videos, 41. And in addition to that, we have a series of videos, what is called GSQL 101, which is a series of very good introduction to the graphs. And you can actually get certified there. And obviously, our documentation is really good, covers everything. And you are always welcome to ask questions on the community forum. Myself, John Herky, and other people from our team, Richard, Bruno, we are happy to answer your questions.
Thanks, Zilad. I think that's all the questions that we have. So I think as we, look at that. Yeah, I'll hand back to you to go through your response.
Yeah, please vote more of you vote. I will keep it up and running, and we will share the results, I guess, when we distribute these slides and the recording. I really would like to know what is needed by the community so that we can focus on that. And no surprise, R and Scala. I guess people who are using Spark would be very interested in this. So please vote. We would really appreciate your feedback. I think that's all for now. Thank you very much for your time today. Here you can see our details. It will be in the slides. You can, as I said, almost always reach me on Discord, where my handle is Szilard Tiger. Yes, the tiger is part of the username. Well, thank you very much for your time.
Thank you, everybody. Have a great rest of your day, afternoon, evening. Thanks again.
Bye-bye.
Thank you. Bye-bye.